Welcome to TWIN BUSCH Germany, your competent specialist since 1997 in professional vehicle workshop equipment. With a corporate headquarters in Germany and 9 other branches in 7 countries, as well as over 40 sales partners worldwide, we are one of the leading manufacturers of vehicle lifts, wheel balancers, and tire changers. Welcome to TWIN BUSCH Germany. I will now show you our headlamp tester TW SWE-B. We will now show you how the device works in principle. First of all, we will check whether the headlight adjustment device is at the correct angle to the vehicle by using the band laser. The laser must intersect 2 symmetrical points on the vehicle. We will then fix the angle again using the foot pedal. Now position the headlight adjustment device in front of the headlight using the targeting laser. By using the laser, the adjustment device can be positioned in front of the headlight very precisely. A highly precise measurement recording is thus possible. At this point, it must be also mentioned that the distance between the headlight adjustment device and the headlight must be between 30 and 50 centimeters. After the device has been aligned correctly, we still need the angle of inclination for the vehicle headlights. This value is usually indicated on the door frame or also directly on the vehicle headlights. The angle of inclination briefly explained. Starting at the headlight, we determine a distance of 10 meters and draw a horizontal line starting from the middle of the headlight. For better visibility, we will change the proportions here. The distance between the upper edge of the light beam and the horizontal line is called E. This is the value that is appropriate for the vehicle and that must be set in the headlight adjustment device. As an alternative to the E value, the inclination can also be indicated as a percentage, as in our case. This results then from the formula of the height difference divided by the distance times 100%. We now set the given 1%. The measurement for the left low beam can be carried out after switching on the lights. We can now see the brightness distribution through the peephole. For an automobile meant for right-hand traffic, we see a light beam that should be flush with the dashed, horizontal line on the left side. Starting at the center, the light beam may edge upwards slightly towards the right at a 15-degree bend angle aligned to the upper line. The reverse situation applies to left-hand traffic. For high beams, an oval light beam emerges, the center of which should be on the upper cross, and with fog lights, the light beam should not go over the baseline. We will then also check the luminous intensity. The luminous intensity between the 2 headlights may differ by a maximum of 20%. We will then also check brightness distribution and luminous intensity on the other side. The measurement is thereby concluded. The headlight adjustment device SWE-B by TWIN BUSCH is suitable for common headlight types such as LED, LED matrix, xenon, laser and halogen lights.